right, we are moving on to rational numbers today. What you're going to be dealing with rational is converting them. So we have vaguely described a rational number. A rational number, if you box off the word ratio, a rational number can be written as a ratio. It can look like a fraction. That's what a rational number is. So we're applying rationals today by converting. That's our goal today. You can convert rational numbers, meaning you can convert fractions. You can either turn a fraction to a decimal or a decimal to a fraction. That's what you can do today. Converting means to change form. You're going to be dealing with whole numbers today, meaning 4 and 2, what do I want to say, fifths. When you convert this rational number, you're going to leave the whole number on the outside. So you're going to go 2 divided by 5 is 0.4, right? And then you just put the 4 on the outside, 4.4. So that's what you do when you have whole numbers. You deal with the fraction part, put the whole number on the side. And any decimal answers you get, only go to 2 spaces, please. That's the 100th spot. Make sure, so you got to use that 1,000th spot to tell you what to do with 100. Remember that. And round to the nearest, 100. All right, so converting. You're going to convert from fraction to decimal, decimal to fraction today. Those are the 2 convertings that you're going to do. When you go fraction to decimal, you go top divided by the bottom. Yay, I love calculators. This is all a calculator. So when I want to convert this first one, in my calculator I'm going 3 divided by 7. 0.43 rounded. 0.43. Make sure you round. If you get 0.42, that is not right. 2 1/8. I want to convert this rational number to a decimal. So again, it's a whole number. I'm just going to deal with my diffraction and put the 2 on the side. So I'm going to go 1 divided by 8 in my calculator. That's 0.125. I am going to, since it only goes to 3, I am including that. And then I'm just going to put 2 on the side. Not when it's 3. When it stops at 3 spots, I go ahead and write that. It all depends. Like if it keeps going and going, then I definitely round. But if it stops right at that 3rd one, I don't round it. Okay, 2 ninths. 2 divided by 9 equals top divided by bottom. 0.222222222. What does that mean? Repeated. 0.2 repeat. Put the bar. It is different. You must include the bar when it's a repeating decimal. All right, so do you feel like you can convert from a fraction to a decimal? Tell someone next to you what you do to convert from a fraction to a decimal. I'm hearing awesome vocab word. You add the fancy one. You divide the numerator and denominator. That is super fancy. I like that. I like that math vocabulary. Second form today, you need to convert, give it from a decimal to a fraction. And here's how. You put the number over the place value that it represents. Okay? So 0.8, my number is 8. My place value is 10. It's a 10, right? Then you simplify. Don't have to be told to simplify, you just always simplify. 2 fifths. Number over place value. 0.14. My number is 14. My place value is tens, hundredths. So I put 100 on the bottom. Have them both. 7 over 50, and I'm done. 1 in 1.45. Okay, the next one, 1.45. Now remember, whole numbers, you deal with them at the end. So I'm dealing with my 0.45 right now. So the number is 45. The place value is 1000. And then I just put the 1 on the outside. Now I can simplify it. And let me take my time here. 5 goes into both of them. 45 divided by 5 is 9. 100 divided by 5 is 20. And I'm going to rewrite that beautifully. 1 and 9 over 20. So, do you feel you can convert from a decimal to a fraction?
Yes.
And the denominator represents the place value the decimal goes to. What do you do with whole numbers?
You leave them till the end.
You leave them till the end. You put them to the side. You deal with them at the end. If you recall from your beautiful formal learning scale, it talks about identifying repeating decimals as rational numbers. That's because you can turn a repeating decimal into a fraction, and it's not what you think. Is 0.4 the same as 0.4 repeating? Yes or no? No, but kids write it the same. If I say convert 4/10 to a fraction, kids are like, oh, okay, 4/10. And then I'm like, okay, convert 0.4 repeating to a fraction. And they think 4/10. And about 95% of kids do that. Because they think the numbers for the place value is 10 that it stops at. But it doesn't stop there, it goes on for infinity. They are not equal. So there is going to be a different denominator. Alright, so this is very, very fancy. Some of you are going to understand it, some of you are going to be really lost. You just quietly watch me. I'm going to be doing some advanced algebra here, and then you're going to look for a pattern as I'm doing this, okay? So here's how we write a repeating decimal as a fraction. The first thing you want to do is assign a variable to represent the pattern. So if you look here, my pattern is 0.4 repeating. So I would say let x equal the repeating decimal. That's what I mean by assigning a variable the pattern. And then I want to multiply by a power of 10. Because that moves the decimal. If you recall from, I think in 6th grade, you learned about metric conversions. When you do like that King Henry died unexpectedly drinking chocolate milk. Remember that?
Yeah.
And the decimal moves around. That's what multiplying by a power of 10 really does. You can move decimals around. Okay, so this is really 0.444444 all the way to infinity. Do you agree with that?
Yeah.
Well, I want to get the pattern to the left of the decimal. So I want to move the decimal one spot. Then I would have 10x would equal, because x is the pattern, then 10 of them gets the pattern over, and then I get 4 repeating forever. Okay? And then we're going to solve. So I'll get the variable alone. Watch, you're going to see me do this. Like I said, some of you are going to catch on to this. Some of you are going to feel lost. The key thing is look for a pattern. That's what math is all about. So look for a pattern as I'm going through this. You'll never have to solve it algebraically, but you do have to know how to write a fraction for a repeating decimal. Let x equal 0.3 repeating. Okay, so I'm converting my repeating decimal to a fraction, and it is not 3/10. It's something different. Okay, maybe you already know what 0.3 repeating is. I'm going to show you how we're deriving it. Some of you already know it's 1/3, but I'm going to show you how to get it. Then I have one number to the pattern, so I'm going to multiply by 10. And that gets the pattern to the left. So I have 3, and then I still have a repeating 3. Now watch what I'm going to do. I'm going to get rid of the pattern. So I'm going to take the pattern away. The pattern is x. I'm going to take the pattern away. 10x, take away 1x, I have 9x's left. My pattern cancels out, and I'm left with 3 on the right-hand side. Now, if you recall from algebra, best subject in the universe, you need to get the variable all by itself. So I move the 9 by doing the inverse operation. X equals 3 over 9, which is 1/3. And that's how you derive the fraction for a repeating decimal. Want me to try again? Kind of? Yeah, great, because I want to. Okay, the next one, 1.72. Repeating. Now, I'm still following that rule on the first page where I deal with my whole number at the end. So I'm going to say, all right, let x equal my pattern. 0.72 repeating. How many numbers are to my pattern?
2.
Okay, now watch what I do. Then 100x is equal to 72.72 repeat. Notice my zeros are the same as the numbers in the pattern. Okay? Now I want to get rid of the pattern so I can turn it into a fraction. So my pattern is x. I'm going to get rid of 1x, which is the pattern. 100x, take away one of them, is 99x's left. Pattern cancels out, and I'm left with 72. Okay, and then I'm going to get rid of my 99 by solving inverse operations. X equals, now watch, 72 over 99. Now I turned it to a fraction. Because this isn't 72 over 100, right? It's different, isn't it? This isn't 3 over 10, right? It was different. It was 3 over 9. This is 72 over 99. It's different. And then I simplify. 9 goes into both of them. 8 over 11. And let's not forget about my whole number, 1 on the outside. Now I want you to stop for a second and try to see a pattern that happened. Okay, so if you think about the patterns that I'm noticing, I have one number repeating, I have 1 9 on the bottom. I have 2 numbers repeating, 7 2, 7 2, 7 2, 7 2. There's 2 numbers repeating. I have 2 9s on the bottom at first. Okay? So if I had 0.5 repeating, how many numbers are repeating? How many numbers are repeating? One number. So it's going to go over 1 9. You put the number over 9. What if I had 0.12 repeating? Is that going to go over 9 or 99?
99.
99. And then, of course, always simplify. Always simplify. So that's our trick. Our trick here, you don't ever have to do the crazy algebra. That is not expected. But you do have to know that it's not over 10 or 100. It's either over 9 or 99 when it is a repeating decimal. So, what should we say? We'll always go over 9 or 99. Or what if it looked like this? 0.123 repeating. How many 9s do you think that would be?
999.
Yeah, that would be, oh, oopsies. So 9 or 99 or 999. Yep. So the bottom number, the denominator, is always a 9 of some sort. So let's practice. Okay, 0.8 repeat. Is that going over 9, 99, or 999? 9, because there's one number. So this is going to be, the number is 8, and it's going to go over 1.